Back. Today we are going to be discussing how we graph tangent and its reciprocal function cotangent, as well as the reciprocal functions to what we've previously graphed sine and cosine. Those names are cosecant and secant, respectively. Here's a nice little chart for you just to keep things straight. The reciprocal of sine is 1 over sine, which is cosecant. The reciprocal of cosine is 1 over cosine, or we call that secant. And the reciprocal of tangent is 1 over tangent, which we can graph as cotangent. A few things in the past is when we just had our calculators, this was how we had to graph the reciprocal functions. But now that we have access to Desmos, we're able to just type in CSC or COT to graph these reciprocal functions, no problem. The biggest thing that we need to make sure of is that the mode we are in whenever we are graphing is radians. Otherwise, your graph will not look correct. Okay, in order for us to graph tangent, we need to know a couple of things. The same is still true with sine and cosine. We're going to pick the values around the x and y axes. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. With tangent, I like to do a sixth coordinate, and you'll see why. And we'll call that 5 pi over 2. That's just a coterminal angle for pi over 2. I added 2 pi to it. Okay, we also know that tangent is the same thing as, and I'll write it up here, tangent is the same thing as y over x, or sine over cosine. So if I were to do y over x at 0, I would have 0 over 1, which is equivalent to 0. Up at pi over 2, 1 over 0 is undefined, UND. Over at pi, I have 0 over negative 1, which is 0. Down at 3 pi over 2, I have negative 1 over 0, which is undefined. Back at 2 pi, we have 0 over 1 again, which is 0. And then my coterminal angle, I'm back up to pi over 2. The coterminal angle is 5 pi over 2, would be 1 over 0, which is undefined. That is how we get the coordinate points for tangent. So you'll see we got the point 0, 0, pi 0, and 2 pi 0. And then these undefined values are the asymptotes of the equation. We have an asymptote at pi over 2, 3 pi over 2, and 5 pi over 2. I like to graph that sixth coordinate so I can see two full waves of tangent, these green functions here. Some important things to know is that we are able to complete one full wave of tangent, you see, between pi over 2 and 3 pi over 2. So that difference, the way we're able to complete one full wave is I would take those two values and subtract them, and that occurs within pi of one another. So instead of the period being 2 pi, the period for tangent, this happens quicker, is just in pi. And then for my asymptotes, I see 3 labeled. And if I were to create a pattern for these, I would say that every asymptote, every vertical asymptote x equals, it starts at pi over 2, and then the distance these are apart from one another is pi, and then n means for any number I plug in, I'd be able to find that asymptote. So pi over 2, if I add 1 pi to it, I would get this. If I add 2 pi to it, I would get this, so on and so forth. Let's look at the same thing now for cotangent. So we know cotangent is the reciprocal of tangent. So graphically, this will look very similar. We're going to pick our coordinate points around the unit circle using the x and y coordinates here. And cotangent is x over y. So x over y, 1 over 0, we're starting at an undefined value, an asymptote. Up here we have 0 over 1, which is 0. Negative 1 over 0 is undefined. 0 over negative 1 is 0. Back to 2 pi, 1 over 0 is undefined. So we only have two coordinates here, pi over 2, 0, and 3 pi over 2, 0. 3 asymptotes, we've got one at 0, one at pi, and one at 2 pi. So same thing for tangent. We're able to complete one full cotangent wave. You'll see that this one has been flipped compared to compared to tangent. And one full wave occurs between 0 and pi. So the period pi minus 0 is just pi. The pattern of the asymptotes is going to be every x vertical asymptote is equal to 0. That's where the first one I see is. The distance between would be pi n. I could just say this as x equals pi n if I want to. So any number I put in for n is where I'd find an asymptote. 0, pi, 2 pi, 10 pi, 11 pi, so on and so forth. Two quick check-in problems. What are the periods for these particular equations? With tangent and cotangent, the formula is not 2 pi divided by b. That is for sine, cosine, and its reciprocals. Instead, it is pi over b. That's my check. So here, the b value is 1/2. So the period would be 2 pi divided by, oops, sorry, I just made that mistake that I don't want you to make. The period is pi divided by b, and b is 1/2. I'm multiplying by the reciprocal here. Pi multiplied by 2 over 1 would be 2 pi. For cotangent, the period formula is the same, pi over b. The b value in this case is anything multiplied by theta, so 4 pi. Here I'd have pi over 4 pi. The pi's cancel out, and I get 1/4 as my period. All right, this last slide displays sine and cosine as well as their reciprocals. So you'll see this function starts at the origin. That's how we know it's sine. It's our wave, our roller coaster function. And if I were to break it apart at these zeros and flip it, I would get cosecant its reciprocal function. So breaking apart at these 2 points and flipping, that graph now looks like a bunch of U's. You start up, down, and then they'll rotate back and forth. So in this first graph, we're seeing asymptotes located at 0 and then pi. And then I think the next one would be over here at 2 pi. There'd be an asymptote here, 0, pi, and 2 pi. So the pattern that we have here is that the first one's at 0, and the distance these are apart from one another is every pi n. We could also summarize that as x equals pi n, just like cotangent. For cosine, this is more of the ditch function. It starts up at 1, travels down, and climbs back up. Again, if I break it apart at those zeros and flip the graph, I'm seeing the u's alternate up and down, and it would continue on too. We've got 2 asymptotes in sight in this graph. One of them is located at pi over 2. The other is located at 3 pi over 2. So what's the pattern? Well, every asymptote it looks like we're starting at pi over 2 plus the distance these are apart from one another. If I subtract this, it would be 2 pi over 2 or just pi. So asymptotes are just a pi apart. It just depends. Are we starting at 0 or are we starting at pi over 2 for those parent functions?